Welcome back. In today's video, we delve into the extraordinary world of fusion power plants, an innovative solution that could revolutionize the way we generate clean and abundant energy. Fusion power plants hold the promise of unlocking the secrets of the stars, harnessing the same powerful process that fuels our sun. Imagine a world where we have access to virtually limitless energy, without the drawbacks of traditional power generation methods. This is the vision that fusion power plants aim to make a reality. Electricity has become an essential part of modern life, powering our homes, industries, and technological advancements. Its significance to mankind is immeasurable, transforming the way we live, work, and communicate. Let's explore the meaning of electricity to humanity and trace its fascinating journey from its discovery to the present day. At its core, electricity is the flow of electrons through a conductor. It is a form of energy that can be harnessed and controlled to perform various tasks. The discovery and understanding of electricity have revolutionized every aspect of human existence. The story of electricity began with ancient civilizations' observations of naturally occurring phenomena, such as lightning, electric fish, and static electricity. However, it was not until the 17th and 18th centuries that significant progress was made in understanding and harnessing this mysterious force. One pivotal moment in the history of electricity was the work of Benjamin Franklin, an American polymath and one of the founding fathers of the United States. In the mid-18th century, Franklin famously conducted experiments with lightning and demonstrated that lightning bolts were a form of electricity. His kite experiment, where he flew a kite with a metal key attached during a thunderstorm, helped establish the connection between electricity and lightning. Another significant milestone came with the discoveries of Luigi Galvani and Alessandro Volta in the late 18th century. Galvani's experiments with frog legs showed that electricity played a role in muscle contractions, leading to the concept of animal electricity. Volta, building upon Galvani's work, invented the voltaic pile, the first true battery, which could produce a continuous flow of electric current. The 19th century witnessed rapid advancements in electrical science and technology. Michael Faraday's groundbreaking work on electromagnetism laid the foundation for the development of electric generators and motors. James Clerk Maxwell's equations mathematically describe the relationship between electricity and magnetism, providing a unified theory of electromagnetism. The invention of the electric telegraph by Samuel Morse and the subsequent development of the telephone by Alexander Graham Bell transformed long-distance communication, connecting people across vast distances like never before. Perhaps the most famous inventor associated with electricity is Thomas Edison. His development of practical electric lighting systems, including the incandescent light bulb, revolutionized the way we illuminate our homes and cities. Edison's work also paved the way for the establishment of electric power distribution systems, enabling electricity to reach a wider audience. The 20th century witnessed unprecedented advancements in electricity and its applications. The harnessing of alternating current by Nikola Tesla and George Westinghouse allowed for efficient long-distance power transmission, facilitating the electrification of entire cities and enabling the growth of industries. The invention of electronic devices such as radios, televisions, and computers further transformed the world, connecting people globally and opening up new avenues for communication, entertainment, and knowledge. Today, electricity is an indispensable part of our lives. It powers our homes, runs our transportation systems, fuels our industries, and enables the technological innovations that continue to shape our world. From renewable energy sources like solar and wind power to the development of smart grids and electric vehicles, the journey of electricity continues to evolve, with a focus on sustainability, efficiency, and reducing our environmental impact. In the quest for clean, abundant, and sustainable energy sources, scientists and engineers have long been captivated by the potential of fusion power plants. Drawing inspiration from the sun itself, these futuristic facilities aim to replicate the process that powers the stars, offering a tantalizing solution to our growing energy needs without the drawbacks of traditional power generation methods. Fusion power plants hold the promise of nearly limitless energy by harnessing the immense power released when light atomic nuclei fuse together. But how do fusion power plants work? A fusion power plant is a type of power plant that harnesses the energy produced from nuclear fusion reactions to generate electricity. Unlike traditional thermal power plants that rely on fossil fuel combustion or nuclear fission reactions, Fusion power plants aim to replicate the process that powers the sun and stars. The core principle of a fusion power plant is to create conditions where atomic nuclei can combine or fuse together to release energy. The most promising fusion reaction for power generation involves the isotopes of hydrogen, deuterium, and tritium. When these nuclei fuse, they form helium and release a tremendous amount of energy in the process. To achieve fusion, a plasma state of matter is required. Plasma is a superheated gas consisting of charged particles, ions, and electrons. To create and sustain the necessary plasma, the fuel, deuterium and tritium, is heated to extremely high temperatures, typically in the range of hundreds of millions of degrees Celsius. This is done using various heating methods, such as magnetic confinement or laser compression. In magnetic confinement fusion, powerful magnetic fields are used to contain and control the plasma. One commonly used approach is called magnetic confinement in a tokamak, which is a donut-shaped device. The magnetic fields confine the plasma and prevent it from coming into contact with the walls of the containment vessel. This allows the plasma to reach the required temperatures and pressures for fusion to occur. Once the plasma is sufficiently heated and controlled, the fusion reaction can be initiated. This is achieved by bringing the fuel nuclei close enough together and providing them with sufficient energy to overcome the repulsive forces between positively charged particles. The heat generated from the fusion reaction can sustain the plasma temperature and further propagate the fusion process. The energy released from the fusion reactions is in the form of high-energy neutrons and charged particles. These particles transfer their energy to the surrounding plasma, heating it further. Heat is then extracted from the plasma using a heat exchanger or coolant, similar to traditional thermal power plants. The heat is used to produce steam, which drives a turbine connected to an electrical generator, producing electricity. Tritium, one of the fusion fuel isotopes, is not naturally abundant and has a short half-life. Therefore, a fusion power plant needs to generate its own tritium fuel. This is achieved by a process called tritium breeding, where lithium is used to produce tritium within the reactor. The tritium is then captured and reintroduced into the fusion fuel cycle. Fusion power plants offer several inherent safety advantages compared to fission-based nuclear power plants. The fusion process itself is intrinsically safe, as it requires precise conditions to be sustained. Additionally, fusion power plants produce no greenhouse gas emissions, do not generate long-lived radioactive waste, and the fuel supply is abundant. It's important to note that while significant progress has been made in fusion research and experimental reactors, such as tokamaks and stellarators, the development of a commercially viable fusion power plant is still ongoing. Scientists and engineers are continuously working to overcome technical challenges and make fusion power a practical and sustainable energy source for the future. That's all for today. Thanks for watching, and don't forget to subscribe for more. Take care of yourself.